Hello everyone, Taki Dheeraj here. Today we are gonna discuss about Posix threads. So topic of this discussion is what are Posix threads and their applications. Level of this discussion is beginner. I am assuming you have GCC compiler is installed in your machine. If it's not installed, just check the description of this video. You'll find the links for the installation. These are the subtopics I'm gonna cover. First, we'll go through what are the POSIX threads, and then we'll see one demo program, how to write a thread program in C, and why do we need them, and applications of a threaded program. Okay, so let's get started with the first POSIX threads. So, as POSIX stands for Portable Operating System Interface, so this is nothing but just a standard name. It's a IEEE standard. So initially it came as a standard, and it's generally linked. Its standard defines the API and as well as uh, it's linked to the Unix operating system. So that's why it's defined as a portable operating system interface. And then what are the POSIX threads? So threads is just it's like a instance of a process. So threads generally share the resources with the process, and they have their own stack. And it generally we can run things parallelly with threads. So let's just quickly see a diagram view of threads, threaded program. Okay, so let me just quickly draw what I'm trying to say. So, in generally a process. So, as we all know, we have process context block, and in that, I'm just gonna draw all the segments in one section. So, generally, we have code segment, as we know, and we have data segment. We have heap, and we also have some open files information. Okay, so these are generally part of a process context. And so what thread is generally is going to do, so in threaded program, so these will be shared with the uh, like parent process. So if it's like a, I can say threaded program, so these will be shared with the processes. And apart from this, what thread is going to have their own registers, their own stack frame. Okay, and we have program counter. Okay, so this will be separate for each thread. So and this will whole will be the one thread program, or we can say one thread is running. Okay, so this is a thread, and this whole from here, so this will be uh, particular thread space, and other than code segment, data segment, and heap area will be shared with the process. This is how one single threaded program looks like. And if we have multiple threads, so nothing is gonna change there. So everything is gonna be same. It's just that this area will be same like this. So we have code, we have data, and we have heap. And obviously we, because this is a process part, so there will be stack of the process also, right? So I just skipped here. So in the thread point of view, if we see, so if I draw it like this, okay, so we have registers, we have stack, and we have program counter. So this will be separate for each threads, stack, program counter, and here also we have registers, set of registers which thread is gonna need during the execution of the like that subroutine. So we have this thread. So this will be the, we can say, these will be the multi-threaded program: thread 1, thread 2, and thread 3. Okay, so as we can see, this whole part above this will be shared with the process which is the parent process. And below this, if we define thread space, so this will be the thread space. This is the first one thread, this is the second thread, and this is the third thread. So what is the benefit of the thread? We can see here is we can say in generally when we create new process, so we have to create this whole process context, including code segment, data segment, heap area, and stack segment, right? So that memory and CPU time is being saved by these threads, because threads just need these registers, stack, and program counter. Rest of the code is generally shared with this process, with the parent process, right? What generally we do in multi processes, like if there are multi processes running in a system, so what we generally do, we generally do inter-process communication to pass on values or to take some values from them, right? But in the threads, as we know, all the resources are shared with the process, so we don't need any inter-process communication between threads. So we can just simply, because everything is shared with them, so we can simply just access those values, right? So it's like a common resource, but we need to aware about the synchronization, because if one thread is writing or reading from the same memory area, so there will be conflicts and it won't be able to get the updated value, right? So there will should be some synchronization that we'll talk about later. But from the uh, concurrency point of view, if I see, so we can say these threads can execute the task parallelly. Okay, so these are like threads running. Okay, so these running generally parallel. So, how threads generally run in parallel? So, one thing is we can say is a time-based thing. So, time slices we generally talk about that in the operating system point of view. So, if a like thread is some thread is starting or thread is executing, so there is something time slice is defined to the thread. So that we generally say that it depends upon on the thread contexting. Okay, so when this contexting comes into picture, when one thread is blocked, for example, this thread is running and it got blocked, so then the what CPU will do, it do the thread context switching, so it will switch to the other thread to execute the task. Okay, so but generally in single CPU, single processor uh, computer, so one thread will be executed at a single time. But why do we see multiple threads running in parallel? Because of this time slices, and as well as because it runs too fast, so we won't be able to notice the difference. But because of time slices, main difference is one thread is executing, and based on the time slice, next thread will be executed, and we see that okay, it's running parallelly. But if we have multi processor CPU, then they can occupy different processes, and they can run this multiple threads on different processes, right? This is the overall picture of threads I wanted to share. So let me just quickly show you a demo program on C. So I have one. This is a demo program I have. Okay, so what generally is trying to do here is we have a basic library for POSIX threads. We call it as a P thread, and I included this header file here, and when I'm gonna compile this, I'm gonna link that library. So what the generally syntax of this, we have this thread ID. So generally each thread will be differentiated with basis on the thread ID. Like we have a process ID in each process, so we have thread IDs here. So here we need to create thread using this call pthread create, and we pass this thread ID here, and null. This is the second attribute of this function, which generally takes the what we want to pass as an attribute, so we can control these threads. So however we want to do it, so there are some parameters on basis of this. Let me quickly show you that. So this is the, we can just run man pthread attribute. So these are the multiple attributes we can generally uh, we can change about a thread. So for example, we want to set the stack size of the thread, and and like that there are a lot of things involved in this, like inherits shed so scheduler based of thing, and we can also set the priorities of these threads, right? So whoever the thread is doing some, like for example critical work, so we need to set the higher priority. Okay, so and this is a function name which we want to exit in parallel, and this is just the argument which we want to pass to the thread. So I just created this thread here. So by this moment when this call will be executed, so the thread id will be filled up in this variable, and this function will be started and executing in parallel. We'll see that in execution, and we have, so I just ran it here because I want to show we are running in parallel to the main thread, because main thread is also going on in parallel. And pthread join is a blocking call, so it will wait till it finds the till this function get executed completely. Okay, so this is a thread id. Based on this thread id, it will wait for to it to join, and then it will just print thread this task is completed. So let's just quickly see this in action. So we have this pthread library. Okay, so it got compiled. So let's say starting thread. So running in parallel, as we can see, waiting for thread to complete, coming two times. I'll explain why it's coming two times there. Okay, so as we can see, running in parallel, these both prints are coming in parallel. So why it's coming like that? Because here I printed sleep one, and here also sleep one. So I'm just sleeping because here I'm just printing, waiting for thread to complete, and then it is going. This thread is running parallelly, and the other thread is also going on in parallel. So both the prints are coming in parallel. So this part of code is executing, which is in the main thread, and then as we created this thread here, and it is running this and printing the this statement in thread statement thread function. Okay, as we can see here, so after pthread join, it got joined the thread, and it got it printed thread task complete. So we can also pass arguments here. So let me just quickly show that. So for example, if I just take a variable here, some value, if I just pass this value here like this, and here if I just want to print, for example, so we have this. Oh, so sorry, we have to change this before. Okay, so we can just run it, and we can see data passed is 12. So one time it's showing value here. So whatever we pass, we can generally see. So you can control this thread however you want to, like however you want to do it. So you can run multi-threaded program also. So how multi-threading will look like? So it will just we can run just this task in a loop, and we can say, for example, j less than 3. Okay, and it will run multiple threads in parallel, and but we have to join these also threads in parallel, and we have to take care of these thread IDs, because this will be overwriting for each threads, right? So either we have to take a array of this, for example 3, like this, and we can just pass based on this thread ID, and we can just pass j here, right? And when we are joining also, we have to join on basis of this So we have to join each threads here. Okay, so let me just quickly write that. Because we are just running a while, so we have to increment also here too. Okay, okay, so this looks fine, and just because we are using the same variable, so we have to take it like this. Okay, so this looks fine. Let's just see what it's showing. Oh, sorry, we have to take this also. So as we can see, 3 threads is starting, 3 times is printing, running 3 in parallel, running 3 in parallel, running 3 in parallel. Okay, so there are 3 threads based on that. So if we want to differentiate them, so we can also see there is one API called pthread self. Okay, so it will print and we can see here what these thread IDs are. We generally take it as an unsigned because it can go to long value and it can interrupt this because it will go to the negative value. Okay, let me just quickly see. So we generally don't pass anything, so it should work fine. Yeah, so as I was saying, so it's a long value, so we have to take it like this. So these are the 3 IDs we can see here, multiple threads. So better to print it inside of this. And we can just skip this our data pass thing. Okay, we'll ignore this warning, I think. Okay, I got it. Because we took unsigned. I think it's expecting pthread type. So let me just quickly change that. Yeah, it will take the format. So we'll ignore the warning for now. So as you can see here, these threads are running in parallel. Okay, so as you can see, thread IDs in each printing in parallel, running in parallel, running in parallel. So they are multi-threaded. So this is called a multi-threaded program. So like that, you can use multiple. You can also, however you want to like it, you can change the code. Okay, so let's jump into. Okay, so we covered them. Why do we need them? As I explained earlier, because in a multi-processes program, so the whole CPU time is being used, and as well as the memory is because there will be separate code segment, data segment, everything will be separate. So that is like overhead for the CPU. So that's why we generally do take threaded program, and applications of a multi-threaded program is could be like uh, so we have a like Chrome browser or any browser, right? So they generally, whenever we open one tab, so that is all these tabs are just nothing but just threads. So this is a one application which is common, and we can also say servers. So like Apache, we can say Apache is a well-known HTTP server. Uh, so what generally Apache server does is, because we are listening on the client requests, HTTP requests, and we are also processing those requests. So what these servers generally do, they take the load, divide this load into multi-threaded programs. So there will be one thread listening for the connection, other thread will be processing the requests, and some other thread will be, for example, getting some information uh, from the wherever the server is being hosted from the system. It's getting some information. So this is like a multi-threaded program, well-known multi-threaded program, we can say. And like that, there are a lot of applications on basis of the threads. So threads is very useful, very lightweight process, we call them, and it's very helpful in many in our daily life. So I hope I covered all of these topics. So that's all from my side, guys. Thank you. Please like this video, subscribe to my channel, and share it with your friends. Thank you.